All right, we're going to go over a couple of examples from 5.7 for today, graphing a couple of functions here. So let's take a look at our first one. So this is the function f of x equals 4 divided by the quantity x minus 6 squared. This is not going to be dissimilar from graphing our rational functions. We want to think about it in kind of the same way, which means we're going to start by looking for our asymptotes. So our vertical asymptote works very much the same way. We're asking ourselves what value is going to cause the denominator to be 0. So we're looking here, and I can see, all right, well, if I plug in a positive 6, that's what's going to cause our denominator to be 0. So x equaling a positive 6 there, that's going to be our vertical asymptote. And then our horizontal asymptote is kind of the same deal as before, which is as long as the degree in the numerator is smaller than the degree in the denominator, it's always going to be that y equals 0. So I'm going to go ahead and just stick those on my graph real quick. This is not the greatest graph for this, so let me do one thing and let's move our y-axis here. So this is going to be 1, 2, 3, -1, -2, -3, because we need a little bit of space. All right, so our vertical asymptote would be at 6. So that's going to be here now. All right, and our horizontal asymptote we said was at 0. Okay. So at this point, we just want to go ahead and just like we did for rational functions, we want to create a table of values. So 3 points to the right would be at 7. Oops, we got a little funky zoom there. At least I did. 7, 8, and 9. And then 3 points to the left would be 5, 4, and 3. All right, so we're going to plug those values in and see what we get out. Okay, so a couple interesting things that you might note here is that we have some repeating values. So that comes from the fact that if we're looking at our denominator, 7 minus 6 squared, right, that's really going to be 1 squared. And then here, 5 minus 6 squared, that's really -1 squared. And 1 squared and -1 squared are both just 1. So we are going to have some repeated values here. So that's kind of nice to note. One other thing is that it's kind of nice to check and see if we're going to have a y-intercept and to get that plotted on here as well. So I'm just going to go ahead and add to my table if x is 0, what might happen. And if I plug 0 in, I do in fact get a value. I get 1/9, and we're going to want our intercept later anyway. So let's go ahead and plot this. So we said at 7, we were at 4, and then at 8, 1, 9, 1/9. And remember, I moved my y-axis over to the left a little bit so that this fit. And then 5, we were at 4. So you can kind of see a mirroring effect here. At 4, we were at 1. At 3, we were at 4/9. And then my y-intercept right there at 1/9. That's a little hard to graph since it's so small. All right. And there's our graph. So the things that you want to include are these asymptotes. We're going to write, we had an intercept, so we had a y-intercept, which was 0, 1/9. And then we want to go ahead and do our domain and range as well. So domain, we're going to be going from -infinity up to our vertical asymptote at 6, and then hopping over that from 6 to infinity. And our range here, We start at our graph, kind of doesn't start quite at 0, but just a touch past, and then goes off to infinity. Because we are on only one side of that horizontal asymptote, we don't have any gaps in our range values. All right, so we're going to do another one, so stick around if you feel like you want to see another one. It's slightly different. Okay, so basically same deal here. The only difference is that we have a cubed value here, but we're not really going to worry about that. Everything kind of works the same, except our graph is going to look just a touch different. So let's get into this. So we want to first find our asymptote. So we're still asking ourselves, if I set the denominator equal to 0, what am I going to get when I solve for x? And we're going to go ahead and get an x equals -4. The degree of our denominator is still higher than the degree of our numerator, so we still have that horizontal asymptote of y equals 0. So I always like to fill those in immediately. They're going to be the basis for the sketch of your graph. Okay, so we've got that, and we want to go ahead and pick our points. Now, when I pick the points that I want to graph, when I go to the right, I'm going to include 0. So my points to the right of this, I'm going to go with -3, -2, and 0, just because I know I'm going to want to be looking for that possible intercept anyway. And then to the left, we're going to go -5, -6, -7. So take a moment, substitute those values in, see what output values you get. All right, so we're back. We have our output values, and we can go ahead and plot those. They're a touch difficult to plot just because a lot of them are very small fractions. But again, you can see we have, similar values. Now, one's positive, one negative. That's because we're doing a cube, so we can get negative values out, but it's always nice to note similarities like that. So let's start graphing. So at -3, we were at a value of 7. -2 is when we start getting kind of small here. 7/8, so it's pretty close to 1, so I'm going to stick that point pretty close to 1. And then at 0, we were at 7/64, so that's pretty small, so I'm going to go a little closer to 0. Go ahead, connect those. Oop. All right, so we're going to approach those asymptotes. All right, left-hand side, -5, we're at a -7, so we're kind of similar looking, but not quite. -6, we're at -7/8, -7, we're at -7/27. All right, and connecting those points, there's our nice curve. Okay, so because we included that 0 in the domain there, when we were making our table, we already have our y-intercept right off the bat. I'm just going to write that as a point, 0, and then comma 7/64, and then domain and range. So domain goes from -infinity up to our asymptote at -4. Then we have to skip that. So then we have a union with -4 off to infinity. And because we're on either side of our horizontal asymptote, we are going to have a gap there in our range, going from -infinity to 0, and then from 0 off to +infinity. All right, guys, if you have questions on this when you're doing a couple on your own, check out the Khan Academy link. It's some interactive practice, or hop into office hours, and I will be glad to help you out.